transmit, to and which route it should add, which source. It means the learning algorithm, for example, the first item O or L or whatever should use from which algorithm or routing protocol the router learns this information. This is the source. Which route should it install in the routing? I mean, the next hop and the destination network address, and should also add the administrative the value, the AD and the metric, which was 110.50, for example. Operating systems in Cisco use what we call administrative distance. Administrative distance help routers to determine the route which should be added to the routing table. Okay? And this value, the administrative distance values, represent the trustworthiness, الموثوقية of the route. So the smaller the value, the better route is. So smaller values of AD tells us that this is really good path to use. Okay, this is administrative distance. So administrative distance help us to determine the route to install within the routing table. This table, based on these root sources, we plug in these values. So for example, directly connected, it's 0 administrative, so it's more trustworthy. Okay, this is 1, this is 5, this is 120. It means that this is the worst that we can depend on. This is the best. It means that we should take the path, we should directly install the path whose source is directly connected. If we don't do this one, the static route is the most trustworthy path to choose if we don't have directly connected network. Okay, smaller values means that better path to install within the routing table. Okay, now we want to talk about static and dynamic routing. Static with dynamic. Static and dynamic routing are not mutually exclusive. Rather, most networks use both of them, a combination of dynamic routing protocols as in static routes. Remember, static routes, we manually configure them. Dynamic routes, routers create paths based on the information supported or provided by the dynamic routing protocols. So static routes are manually configured, whereas the dynamic routes depend on routing protocols to determine these routes. Static routes are commonly used in the following scenarios: as a default route, forwarding packets to a service provider as a default. So we define statics to define default route. For routes outside the routing domain and not held by the dynamic routing protocols. So for the place that we can't use dynamic routing protocol, we use these static routes. So if this appears somewhere, we use static routes. Or when network administrator wants to explicitly define the path for a specific network, and this is really important important for security. And we can also define static root for stop networks. Remember, stop networks are the networks that only have that a router has one source and we only have one path between these nodes. So static routes are useful for smaller networks. If we have a small network, we manually configure all the IP addresses for this topology with only one path to an outside network. In order, we create network, okay, and we make only one path to the outside. This is enforced. This is improve the security. So they also provide security in a larger network for certain type of traffic or links to other networks that need more control. If we want we create static routes sometimes for whole network in order to oblige the path or the traffic should be entered only to this path, to this static path. Why? Because we may install firewalls, we may add some security check or validation or detection or inspection. So we oblige the internet traffic to pass through static routes, and this is for security. Okay. Dynamic routing, static or dynamic continued. So dynamic routing protocols are implemented in any type of network consisting of more than just a few. So for large number, for a network that has large number of routers, we use dynamic protocols because we depend on the dynamic routing protocols to help creating and maintaining and updating the routing tables. So this is so for small networks we use static routing using static routes, and for large networks that use large number of routers we depend on dynamic routing protocols to create and to automatically determine the best routes if the topology changes. So remember, dynamic routing protocols, when routers share information, all of them each one creates its routing table on its own by itself. Okay. And if any change happen within the topology, the routers transmit to each other the update information, and based on this updated information, each router change or update its routing table with this new change. Okay. So dynamic routing protocols are used if a network consists of large number of routers and not just a few routers. When it change in the topology requires the network to automatically determine another path. As I told you, in a static case, the routers and the network devices are manually configured. And if we lose some connection or a node will go away or router will be off, you should interfere. You should go there and reconfigure manually this information as a network engineer or administrator. However, for the dynamic routing used in large networks, no. If one router goes off or down, the dynamically routing protocol will transmit this information to its neighbors in order to recreate, to remodify, to reconfigure to re-update their routing tables in order to take into account this change. So this is very important, and using routing protocols are important when the network is scalable. That means we don't expect the size of the network. So for scalability, as the network grows, the dynamic routing protocols automatically learns about any new networks. So each router will know about its neighbors, and each other router will receive these updates, and you see if there is some change, okay? Each router will transmit to its neighbor, and each neighbor will transmit to other neighbors. So after we update all these routing tables of these at these routers, and the network, we say the network converges. It means converges when the routing tables at each router will stabilize, will now know this is the final topology of the network. This is the convergence. So the table compares between the dynamic and the static routing configuration. So this is the dynamic routing, and this is static routing or routing. Configuration complexity for the route dynamic, it's independent of the network size complexity, because there it depends on some protocols to configure the network as DHCP or what else. However, the complexity using static, as the network size increase, we should interfere, we should do lots of work in order to configure each device by itself, okay? So this is increase the complexity. Topology changes, it automatically adapts to topology change, because the routing protocols, dynamic routing protocols knows about this topology change, and based on that they transmit updates to their neighbor routers, and each one will update its routing table based on this topology change. However, if the topology change for static networks, the network administrator engineer should go and should reconfigure this network topology change. Dynamic is scalable, which means for simple, suitable scalability when using dynamic routing, it helps us, or it's good choice for simple networks and also for complex networks, because each router depends on the routing protocol to update any change. So all the routers at the same time will use these updates to have a converged network eventually. But if we use static routing, we usually use it for simple topologies, small network size, okay? Security must be configured within the routing, dynamic routing networks. However, it's